All right, today's lesson, or this lesson, is 10.3, the first one. It is over geometric sequences and series. Actually, this part, 10.3, the first one, will just be the geometric sequences. 10.3, the second one, will be the different series. So, geometric sequences. Okay, a lot of similarities to the arithmetic sequences, but some key differences. All right, basic difference, a geometric sequence is where the consecutive terms have a common ratio. Something is being multiplied. So find the next three terms in the geometric sequence, 27, 135, 675. Okay, this is no longer arithmetic. There's not a common difference. There is something that's being multiplied by the 27 to get to 135 and multiplied by that to get to 675. Well, the way you figure that out is you find your common ratio. It's any term divided by the previous term. So 135 divided by 27. You might need a calculator for some of these, but that gets us an answer of 5. If I did 675 divided by the term before it, 135, again, we get 5. So it's a common ratio. So continuing on, how do we find the next three terms? Well, in this case, since my common ratio is 5, we're going to multiply by 5. So 675 times 5. And we get 3,375. Take that answer times 5. I'm cheating. I have the answers here in front of me. It's already been punched out in the calculator. Next term, multiply that answer times 5. 84,375. So those would be your next three terms in this geometric sequence. All right. Again, we're kind of doing the same idea that we did with the arithmetic sequences. So here's a geometric sequence. We're going to identify its formula, its pattern. So again, this is our first term. This is the second term, third term, fourth term, and the fifth term. In this case, it should be easy to tell that each term is being multiplied by 2 to get to the next consecutive term. So our second term, though, is the first term of 8 being multiplied by 2. The third term is that first term of 8 multiplied by 2 2's, and so forth. So with that in mind, jumping all the way to, say, the 10th term, how would I find that? Well, it would be that first term of 8 times how many 2's? Should be 9 of them. So 2 to the 9th power. And that will lead us to our formula for the nth term of a geometric sequence. So the nth term of a geometric sequence will be our first term times that common ratio to the power of n minus 1. So don't confuse your formulas. You have to know whether it's an arithmetic sequence versus a geometric sequence and use the correct formula. All right, write the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. All right, if it's a question like that, they give you the term, they want the next however many terms, in this case 5, just count. So in this case, the counting is acceptable and actually the whole point of the problem. Common ratio is 2, simply means multiply by 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24, one more, times 2 is 48. Easy enough. Now, flipping the page, number 3, find the 15th term. Okay, I don't want you counting 15 terms. We don't want the 13th or the 14th, etc. We simply want the 15th term. Now we're going to use the formula. So 15th term, n is 15. First term is 20. Common ratio doesn't even pretend to be pretty, 1.05. And since n is 15, 15 minus 1 is going to be to the 14th power. And at this point, I'd be just reaching for a calculator. As much as I don't like calculators, this is definitely a calculator problem. So, cheating again, I'm looking at my paper that has the answers. 39.5986. And 1.05 to the 14th power will have lots of decimal places, so that's obviously a rounded answer. By itself, that should have 28 decimal places to be specific, but not worried about that. All right, number 4. Find both an explicit formula and a recursive formula. So again, just like we did yesterday. All right, for the nth term of this geometric sequence. So first term, we got that. Common ratio, any term divided by the previous. So 15 divided by 5 tells us our common ratio is 3. So the nth term would be the first term times r to the n minus 1. That is the explicit formula. There's no way to clean that up. That's it. Now, as far as the recursive, really the easiest way to look at the recursive is what we were doing here. What do we do? Each term times another 2. Each term times another 2, etc. So it's simply going to be where each term is going to be the previous term times whatever that common ratio is. Now, once again, when you're doing recursive, you do have to have a starting point. So we do have to start with the fact that our first term was 5. And then after that, each term is going to be, common ratio was 3 times the previous term. And together, that makes up your recursive formula. Because I should probably write that somewhere, shouldn't I? It's just the recursive one. Number 5, whoops, too far. Write a sequence that has 2 geometric means between 480 and negative 7.5. So 480, 2 geometric means there's 2 numbers in between, and negative 7.5. So what that tells us is that, besides the fact it's a geometric sequence, we know the first term is 480, and we know the fourth term is negative 7.5. We're looking for the second and the third terms to go in the middle. So, using our formula, and the fact that we know the fourth term, so that's what we're going to start with, then is a subscript 4 equals a1 times r to the 4 minus 1. Let's see, fourth term is negative 7.5. First term is 480. It's that common ratio that we don't know. All right. That's what we're solving for. Solve for your unknown. All right. And this got into some nasty decimals. Doing this with the calculator. Put that down a little bit. All right. So negative 7.5 divided by 480. Punch that out in the calculator. We got negative 0.015625 equals r cubed. Okay, I don't want r cubed, I want r. So how do we get just r? We take the cube root of both sides. So take the cube root of it, and when we do that, we find that r is simply negative 0.25. So now that we know that, going back to the original problem, first term of the sequence is 480. Multiply by negative 0.25, or a negative 1/4, and we would get negative 120. Now multiply that again by negative 0.25, negative 1/4 will get us a positive 30. Multiplying that by negative 0.25 gets us a negative 7.5, and we are good because our first answer matched, our fourth one matched, so we didn't screw up anywhere in our arithmetic, but the whole sequence is the answer to the problem. All right, now last one, number 6. This one's a little different. Now, the fourth term of a geometric sequence is 125. R is 1/5. Find the ninth term. Okay, do not write this. Okay, it's going to be correct, but it's going to be the long way. We're not going to do it that way. But real quick, I could start with the fourth term. Well, there's our formula. But I could start with the fourth term, and from this, solve for A1. And then come over here and find the ninth term now that I know what A1 is. Okay, that would work. Nothing wrong with it. But there's a shorter way to do this problem, a little more direct. If we're trying to go from the fourth term to the ninth term, the ninth term will simply be the fourth term times how many more r's? It should be 5 more. So to get from the fourth term to the ninth term, I just need to multiply by that common ratio 5 more times, or simply r to the 5th power. So in this case, that would be a much easier formula because I already know the fourth term and I already know my common ratio. So the ninth term will simply be the fourth term, which is 125, times my common ratio of 1/5 to the 5th power. And again, I would just punch that out in the calculator. Much as I don't like calculators, these are problems that probably require it. Although actually 125 is 5 cubed, so should have been able to probably figure out it was just a 5 squared in the denominator. If we were looking at it close enough. All right, and that is 10.3, the first one. Okay, it's geometric sequences only. The series will be the next lesson.